welcome to Thrashing Code, my channel here. I'm Adrian. I'm going to be the one slinging the code for you today on the channel. And we're going to tackle a problem, another fairly easy one, fairly easy. There's multiple context to it, like you're following multiple steps here. So what we're going to do today is take an IPv4 address, 4 octets, such as 192.168.0.1. That's a pretty common one to hear. And we're going to take that and we're going to turn it into an int, a 32-bit int. Now, we're going to go into a 32-bit int for a fairly simple reason. Each octet within an IP address, so there's four octets. Each octet is 8 bits. Okay, see the connection there? Octet, bit, etc. So the first octet is 8 bits, the second is 8 bit, the third is 8 bits, and the fourth is 8 bits. All even bits, right? And when you have 4 8-bit numbers, you have a 32-bit int. Hey, it all comes together, right? So that's what we're going to do. We're going to turn that IPv4 address into basically a 32-bit int. Easy peasy, right? The way we do that is, let me put these up on a screen. I'll type some things so it makes more sense, right? Here I have the project. I haven't added the projects, but I'm going to add just a file to type in. Let's add a file. Yeah. The idea of the problem. All right, now. So an IP address looks like this, 10.0.0.1 or like 192.168.0. Say .0.1, like that, right? So that's 2 different ones. One of them is actually considered private, one's public. But anyway, we're going to get into that later on a subsequent variant of this problem. But right now, we're just going to do the simple thing of taking one of those 4 octet IPv4 addresses and turning it into an int. For example, let's take a weird one. Let's go with 128.32. I'm picking numbers I know how to do. 128.32.10.1. Yeah, so we got 128.32. Those are pretty well-known numbers within the IP range. 10 just for kind of a weirdy one, and then 1 just to get it as simple as you can. Now, if you took the binary of each of those, you'd have, let's see, this would be 1, 0, 0, 0, 0, 0, 0, 0, I believe. I might have gotten my zeros off by hitting it too many times, so don't sue me, but you're getting the idea. This is the binary representation of the number. Oh my God, look at that. The AI is going crazy. It's also wrong if it's trying to do the last number. So anyway, 1, 2, 3, 4, and then 1, 0, 1, 0, it's 10. And then we got 1, 2, 3, 4, 5, 6. And there. So that would be our number in binary, right? So that's 128.32.10.1 in binary. And then if we put all those together, let's see here, let me calc this sucker. All right, so let's see here. We got first one would be 2 to the power of 31. So let's, I think I can copy that. And let's put it here, yeah, there. And then we have 2 to the power of 22. And then 2 to the power of 12, which is 4096. And then 2 to the power of 10, right? 24. And 2 to the power of 8 is 256. 2 to the power of Z is 1. So add those up. Add this list for a total of, did it do it? No, it didn't do it. Okay, I'm supposed to be doing the AI in the next subsequent thing, but I'm not. I'm doing it this way. So let's do this. 214, 748, 748, 3648, 3648, plus 419, 4304, 4304, plus 4096, plus 1024, plus 256, plus 1 gives us this number, I think. Okay, that theoretically would be the end. That would be what we get. So just to backtrack here for a second. So the way this works is you basically take this number, right, the 4 octets, and you give yourself the 32-bit binary number, right? Now each of the binary numbers, so from let's see, left to right, it would be, it's 32-bit, so you're going 31, 30, 29, 28, and so on, right, like that. Now with each of those, you now have, the first one's a 1, right? So you do 1 to the power of, well, let's put it this way. That one's on, so you get 2 to the power of 31 like that, and then you're going to add it to the next one, which is going to be, oh, did it just do it for me? Pretty much this. But let's see, so the next one that's on is, let's hear, 30, that's 30, 29, 28, 27, 26, 25, 24, 23, 22, 21. So, wait, is that right, or is that the 20th position? I think it's the 22nd position. Yeah, so anyway, you go down here to like the 22nd position, and that one would be on, right? So this calculation would be on, which means that one you're going to add. All the rest of these are going to be zeros, right? And then you go on down the line, and that's where I did these, because I looked at it and counted that out in my brain, and then we calculated these out, added them up, and boom, we got this number. And I think I did it right. Again, I just quickly looked at this, and I was like, all right, we got, what is it? We got 31, then we got 22, and then we got 10, 8, and we have the 0 position too. 0 position right here, which just ends up being 1, etc. So that's how I got this number right here. Okay, so all those calculations aside, let's just get those out of here. And we can kind of use this as an example, right, to build our first test in this project. So let's go ahead and create a project, create a unit test library, and we'll call it, what should we call it? How about IP converter tests? There we go. And then, is it going? There we go. And then we want to add another project, and it's just going to be our class library, and we'll just call it IP converter. There we go. It was weird that unit test one took 10 minutes to create practically, it seemed like. All right, and as always, I like to just run this real quick, and poof, we should have it, and it should succeed because I have assert.pass in that. I've just left the default thing in there. Okay, and then let's call this converter tests, and then we'll use the little shortcut, apply rename refactoring, and let's look here, and it did not rename the thing to the file though, so let's rename to match file. There we go. And then over here, did I just create 2 test projects? Which is not what I was trying to do. Yeah, that is not what I was trying to do. So let's just delete this entirely, and I'll recreate it. You get a nice video edit. And poof, barely noticeable, I just recreated this. We're just going to call this converter, and that's going to be our actual class. We'll rename the file to match the class as such. And we're ready to get off to the races. All right, so first test. Let's get rid of this thing and actually put something in here. All right, and then what did I do with my stuff here? So I want to make sure this is, I feel like I probably got that off, but we'll figure it out in just a second. Because when the test runs, if it breaks, we'll actually get the calculation because we'll make it do it programmatically, and I'll get that right. I'm sure I'll get that right. All right, so we're going to test IP to int. All right, so assert that, let's see here, IP convert dot to int 32, and then we'll give it the IP, and then we'll say is that equal to, what was my number? The one that's probably freaking wrong, but the way I did the calculation, that I explained the calculation, that is the way you do the calculation. I just don't know if I actually got all of them, because like I was saying, I eyeballed that binary and I just did the calculation. So I might have been off by one on one of those, you know, programmer error and everything. So anyway, we got IP converter. So let's go ahead and bounce that in and create the type. We'll make it a class, and then there's some bunch of stuff already. And then we want to do toInt. Oh, did it actually say? Yeah, it did actually say toInt. Create method. Blah blah blah. This static. What do I want returned? I want a int 32 specifically. That's what I want returned. String is the IP address. I think something like that, right? Or let's just call it IP, easier to type. And then that should be good there. What is this fussing about? Oh yeah, let's make it abstract, and then we're gonna actually take it and go put it in its class library. Whoops. Oh, and then I named this one this. So let's actually make the file, rename file to match the thing. Yep, okay. And then we got toInt in there, and then I'm gonna run the test again just to make sure everything's there. I'm gonna reference it. All right, and now we're gonna run this puppy. And what do we got? All right, failed, as expected. I didn't even have the IP address in here. Let's put the IP in. It was 1.32.10.1, right? That's what we were using. Right, where's my file? Here's my file. 128.32.10.1. Yep, that's what we were using. Okay. And then in here, that is obviously not going to give us our calculation. I'm going to ignore that. Stop telling me. Okay. Can I just turn off this for a second? Just stop working for a minute. Open, disable completions. There we go. All right. Because I just want to do this off the top of my head. So first, we're going to have a string, and it's going to be an array because we're going to have it hold the octets. And then we're going to do IP.split on the dot, because it's a dot or a period, right? And that should give us the 4 octets. And then we're going to have a int, I think. And then just have it be the IP number. We'll make that 0. And that'll be used for our, well, you'll see. Let's see here. All right, so IP number plus equals, we're going to do convert dot to int 32. Let's do octets, right? Did I spell it right? Oh, I have a, let's see here. Let me rename that to the word. Rename to, yes, just do there, octets. That's octets. There's no C in there. I don't know why I put that in there. All right, so we got that, and then we need to convert .octets, and then we need to, we need to bit. Well, first we need the right array. So we're working on the first one, and we need to bit shift that. The first one is So bit shift it by 24 bits. So that's a left bit shift. And then I think the next one should be 16, and then we're doing 8, and then yep, that's the last one, and that'll be third position, second position, and first position of the array. And then we return the IP number, right? So that should, so when we convert it here and do the little bit shift, that should give us the total to put into IP number. Starts out at a 0, right here, and then it just adds it up to this, and then we can return that IP number. And we want it to be a 32-bit IP number, and that, I think that will work. Let's run the test. Erp. Too small for a uint. I'm not using a uint. Wait. I'm not using a uint. But do I need to use a uint? An unsigned int? I think I need to use an unsigned int, don't I? Yeah, let's actually do that. Unsigned int 32. And then, well, does that, oh, fiddlesticks. What is 2 int 32? Oh wait, is there a unsigned int 32? Okay, there we go. All right, so let's convert that. And then return. Oh, I need to change that to this. No, I need to change it to dad burn it. Why did? There we go. So I changed it to unsigned int because that should give us the full range, the full positive range. Because if we're just using an int, that's the negative to the positive, right? The full, that range, which would give us the half of what an unsigned int would be, because that would be the full positive, right? Yeah, so maybe that will do it. I bet it's probably right. What, 215, 21? So this? Yeah. 24 bit 16 8. Okay. Is that right, you think? What is this fussing about something? Oh no, it's just telling me that stuff. What is this saying? Use type. Oh, uint does, I guess it decides? I don't remember C#. C# people, feel free to tell me about that. What does that one do? I guess it makes it an unsigned int, but it just makes it like, doesn't it resize it? Don't you need to say unsigned int 32? Anyway, I guess that's what it wants to do, so I'm going to let it do it. All right, so that should pass now, right? Wait, I just put in the expected one. Oh, the number was that the expected was what I had. So if I put that in, then that should pass. Bloop. All right. Okay. I think I got it. I think that's gonna be pretty good. Let's add some more. Let's add some more tests, because obviously one test is leaving a big gaping hole. Let's actually add tests too. Unlike how I've kind of been doing it the last couple times, where I'm just like, just add a bunch of asserts in one test, which is not actually really good practice. So let's do test 0 IP, or that doesn't actually make sense. Let's test IP to int all zeros. I'm going to do that. All right, and then that would be assert dot that IP convert dot toInt32, and then we're going to do the Z one. That's British for 0, by the way. Is equal to, why does that not work? Oh, is dot equal to, there we go, some number, which would be Z. All right, and let's see, does it let you do, does it let you do a message like incorrect answer for IP 0.0.0.0, like that? Does it let you, whoops, does it let you do that? Okay, let's see if we get that one. Hey, that passed too. All right, so I'm gonna run both of them at the same time, just to, there we go, got updated test. So now let's do oh, let's do a calculation like this. Test, where we kind of just add cruft. Void, we'll do test IP toInt leading zeros. Does that have is that just maybe zeros like that? I think that's how you pluralize zeros. It might actually have an E in it. It's one of those weird English rules and gets me confused sometimes. Anyway, assert that, and then let's do an IP convert dot toInt32. On these toInt30, do I really need to rename that to? I almost need to rename that to unsigned int32, right? But anyway, let's see here. So I'm going to do leading zeros. This is almost just to see like what is that I get is equal to. Let's do, I don't know, some random number. Then incorrect answer for IP equals 0.0.002.003.004. Whoops, 4. And then, all right, so that might break. Yeah, that broke. Okay. Well, obviously, because I put in this crud number to actually get the number. So this should be the number, if my code is still correct. So I'm going to get that in there. Let's see, what is it? What was it again? 169.090.60. Okay. And let's add another test around. Let's do like public void test IP toInt random IP, just whatever, some random IP. And I'll pick, let's do assert dot that IP convert dot toInt32 is, let's go with 192.168.0.1. That's not really random, but that's the one I'm picking. And then I'm going to say is equal to, I always do that, is equal to, there we go. I'll do 2 again because I don't know what the number is. 192.168.0.1. Yeah, I don't know. If I go here and then do incorrect answer for IP. Did it just get rid of my, oh no, it's there, okay. 192.68.0.1. Boom, boom. Let's do boom, boom. What messed up my stuff here? Oh, I don't need a leading one. There we go. Okay, I got it. Now let's see if all these work. So most should pass, but the one is going to break. Incorrect answer. Okay, it was this calculation. All right, so now that we've done that, that at least gives us a fair bit of code coverage. And let's see, we should, yeah, all of them are passing. So now let's talk refactor here. Okay, so right off the bat, I was just thinking, like, if we like looped over these, like maybe a for each, or maybe if we did select off the returning array to go through the array, right? So we used a select as a for each on the loop. So if we did something like, let's do return ip.select, and off of that, those, and then we did a select off of that where each of the remainder bits is the octets. We moved off of that. We did convert dot 2 and 32. Whoops, that's not what I want to convert dot. Oh yeah, 2 and 32, and then I want to do the particular octet that I'm on, and then I guess it's going to be, is it going to be the sum? No. So we need to aggregate all the totals, right? So that select is basically doing what's being done up above. I might need to multiply this or something. But I think do we have like an aggregate exception? Maybe, aggregate. Let's see here. Yeah, I don't know what I'm doing there. You get the idea. I'm trying to loop through that. So loop through it so that I do each of these things, because it's basically the same thing is happening. It's being converted to an int in every situation here. So if we're on each element of the array and we go through the array and we don't do it specifically by the bit offset here, and instead let's see, for each octet, we left shift the result by 8 bits, but then if we add the octet to it, we could theoretically, would that work? I think. So if we offset it just by 8, and then add the current octet. I think that would work. Let's see here. Let me. Okay, so this bit works. So that's not what I want to do. Let's go all the way back. All the way back. There we go. We're going all the way back to here, and then this is going to be a save point here again. Commit first draft. That works. Okay, clear. Now, so we got, this should be just uint too, right? Introduce type. No, that's not what I wanted. Uint, not unit. Uint. There we go. Okay, so now it's like the IP one here, and then this is probably saying make it a var, right? Yeah, of course. Okay, so that's a little bit of refactoring. But okay. Yeah, I don't know. This one's, I'm kind of perplexing myself. So let's try this. We got all that in there, so we can just roll back if we need to. I'm just gonna nuke all this stuff. And I'll put return, because this has got to work, right? The thing that I'm thinking here is, okay, we're going to split it on that, and then that's going to give us the array elements to work through, or list elements in this case, I guess. But then we're going to select off of those elements so that we're doing something to each of the elements of the array that we just created by the split, which the result of the split is the array. So then in here, we're going to have an octet. I keep trying to spell it with a C. There's no darn C. Convert to unsigned at 32. And then in that would be the octet. And then it would be the aggregate of it, which is the result. Okay, not result. Octet. So, darn it, octet. Oh, this will need to be in parens. Result octet. So it'll be an unsigned int, and then the octet itself. And then here we'll go the result. Dad burn it. Result bit shift. Sorry, erp by 8. Then add the octet to it. And I think that might work. Okay, so I'm doing the split. Then on each of the array elements, I'm doing a select of the octet, which is the element within the array result, or yeah, the array result. Oh yeah, it says it right here, string array result. So it makes, and it's stepping over it, you get IEnumerable as it's converting to int the particular octet. So then each of those would be the octet in int format. So then the aggregate is those bits, bit offset plus its octet, its respective octet, which would then give us a result that can be returned that's aggregating on the octet. Yes. All right. Let's run it. Oh wait, did I just do it? Shortcut. Get out of here. So going back over here, I like to run it this way, and then yeah, cool. All right, we got complete success. That's a really damn slick way to do it right there. So let me copy this, and then if we go back and we look at oh yeah, let's uint. Okay, so if we look at what we did here, it's functionally the same thing as being done, except we have the string array, which is an array of each of the elements split on the period. So we have a first octet, second octet, third octet, fourth octet. Then our holder value, the IP number, which is going to be the one we're aggregating, starts at 0, of course. And then we get our IP number plus equal to the IP number plus the converted .toInt octet position to its particular octet bit shift. And then it adds each one of those respectively. Right? And returned. And then that is what I rewrote it to. And that's working. So hell yeah. Nice refactor. So in the next post, what I'm going to do is whip out the old AI tooling and see how fast it can extend the capabilities here. That's what we're going to focus on. We're going to try to basically write 3 or 4 more tests, maybe 5 or 6, and see if we can't get that added. And I may extend it to like figure out what, I don't know, do some calculation off of it based on something you have to do with IPs. So think of that and we'll come back to it. Also, in the very near future, I actually change this to Go, because that's something, this is the type of program that you definitely would be writing in Go. Go does a lot of systems code, and thus you're dealing with IPs and other calculations like that. Maybe we'll do like an IP4 to IPv6 calculator, or something of that nature. But anyway, what we've got today is basically an IPv4 to int32, unsigned int32 converter. So we start with our 4-octet IPv4 address, and we convert it into a 32-bit unsigned integer value. And with that, that's a wrap. We got it done. It's working. We got some tests passing, and we're ready to ship it. So ship it, and I will catch you in the next video where we throw some AI tooling at it and see what AI comes up with. In the meantime, everybody happy thrashing code. Cheerio.